In this video, we'll talk about balancing chemical equations. So when you have a balanced chemical equation, it reflects the law of conservation of mass, which is basically that matter cannot be created or destroyed. So the reactants that you start out with have to have the same mass as the products that you end up with. So a balanced chemical equation will show that there's the same number of each kind of atom on both sides of the equation. So in order to balance a chemical equation, you're going to add numbers in front of the appropriate formulas, and these numbers are called coefficients. So here's an example of a skeleton equation that needs to be balanced, and it can be balanced by adding this 2, which is called a coefficient. So an important point is that you can only add coefficients to the skeleton equation. You can't change the subscripts. So here's another example, copper 2 oxide producing copper and oxygen. So you can see that on the reactant side, there's only 1 oxygen atom, and on the product side, there's 2. And so you might be tempted to just add a little 2 there, because then it's balanced. But you can't do that because that's changing what the compound is. So instead, you have to put the 2 out in front. Then you'll notice that that also affects the copper, right? So then we balance it by putting 2 copper over there. So now it's all balanced. Another important point is to make sure that that coefficient gets multiplied in. Right? It applies to all the atoms in the compound. So as an example, if you had the coefficient 3 in front of Fe2S3, and you were counting atoms, you would have 6 irons, 3 times 2, and 9 sulfur, 3 times 3. So how do you actually balance a chemical equation? So in general, balancing chemical equations requires a lot of patience and oftentimes a lot of practice. For some people, it comes naturally. For other people, you have to work at it. Basically, you need to find the way that works best for you. Okay, there's different ways of doing it, and you have to figure out what works for you. But I'll give you some tips. So the first tip is to make a table of atoms for each element, showing how many are on each side of the equation. So we'll go through this example, aluminum chloride plus potassium, creating potassium chloride and aluminum. So we set up a table, and we write on the left side, we put the different atoms that are involved in the reaction. So we've got aluminum, chlorine, and potassium. And then we count the number of each on the reactant side and then the product side. So on the reactant side, we have 1 aluminum, 3 chlorine, and 1 potassium. On the product side, we have 1 aluminum, 1 chlorine, and 1 potassium. So looking at our table, we can quickly see that the chlorine is not balanced. There's 3 on one side and only 1 on the other. So we need to balance the chlorine. So we can do that by putting the coefficient 3 in front of KCl. Now we have 3 chlorine. But in doing that, we've also changed the potassium. So now we also have 3 potassium. So now aluminum and chlorine are balanced, but potassium isn't. So we need 3 potassium on the reactant side. So we can get that by putting a 3 in front of the K. We now have 3 potassium on the reactant side as well as the product side. And now we check and everything is balanced. The next tip is to balance polyatomic ions that appear on both sides of the equation as a single unit. So in this equation, you see the sulfate polyatomic ion, SO4. So leave that as sulfate as a unit of SO4. Don't split it up into S's and O's. Leave it as a unit. And you can do that because it is a unit on both sides. There's an SO4 in the reactant side and SO4 on the product side. So if we set up our table, we have H's, We have SO4s, so keep those as one thing. We have iron and sulfur. So we'll count them up. On the reactant side, we have 2 hydrogen, 1 sulfate, 2 iron, and 3 sulfur. On the product side, we've got 2 hydrogen, 3 sulfate, 2 iron, and 1 sulfur. Okay, so we see that hydrogen and iron are currently balanced. So let's work on balancing the sulfates. So we need 3 sulfates on the reactant side. So we're going to put the coefficient 3 in front of H2SO4. We now have 3 sulfates, and those are balanced. However, we've changed the number of hydrogens, so we now have 6 hydrogens. So the hydrogen's still not balanced, and the sulfur is still not balanced. So if we look at the hydrogen, we've got 6 on the reactant side and only 2 on the product side. So we need 6 on the product side, and we can get 6 by putting a 3 in front of H2S. 3 times 2 gives us the 6. That's also changed the sulfur. So we now have 3 sulfur, which worked out nicely because that was the other one that wasn't balanced. So now we're all balanced. Now, if you have a polyatomic ion and it's not on both sides, if it gets broken down during the reaction, then you have to break it down. You can't keep it as a polyatomic ion. And remember that if the polyatomic ion's in brackets, the subscript has to apply to all the atoms in the polyatomic ion. So in this example, HBr plus FeOH3, creating FeBr3 and H2O. We set up our table. So because OH as a polyatomic ion doesn't exist on both sides, we need to break it down. So we've got hydrogens, we've got bromines, iron, and oxygen. So on the reactant side, there are 4 hydrogen, 1 from HBr and then 3 from FeOH3. There's 1 bromine, 1 iron, and 3 oxygens. On the product side, we have 2 hydrogen, 3 bromine, 1 iron, and 1 oxygen. So right now, the only thing that's balanced is the iron. And we're going to leave the hydrogen for now, just because it exists in 2 different molecules, and so it's a little more complicated. So let's start with bromine. So we're going to balance bromine by putting a 3 in front of HBr. So now we have 3 bromine on each side. That's also changed our hydrogen. So now we have 6 hydrogen on the reactant side and 2 on the product side. So the next thing we're going to balance is the oxygen. So we're going to balance the oxygen. We have 3 on the reactant side, only 1 on the product side. So we're going to put a 3 in front of H2O. That's going to give us 3 oxygen. That also changed the hydrogen, so we update that. We now have 6 hydrogen, so it all worked out in the end. So now everything is balanced. So the next tip is to start when you've set up your chart and you see that a few atoms are not balanced. Which one do you start with? So start with an element that occurs only once on each side of the equation. So if you look at that example, oxygen occurs in 2 different compounds in the product side, right? There's oxygen in carbon dioxide and there's oxygen in water. So you would want to leave that till the end, right? Start with either carbon or hydrogen. And somewhat related to that is leave any elements that occur in the uncombined state for last. So in this example, O2, right? That's oxygen is uncombined with anything else. And so you leave that for last because you can put whatever coefficient you need in front of oxygen to balance it, and it's not going to affect any other atom. So let's do this example. So we've got carbon, hydrogens, and oxygen. We have 5, 12, and 2 on the reactant side. And on the product side, we've got 1 carbon, 2 hydrogen, and 3 oxygen. Okay, so we're leaving oxygen for last. We'll start with carbon. So we've got 5 on the reactant side. We want 5 on the product side. So we're going to put a 5 in front of the carbon. Now our carbons are balanced, and we've changed our oxygens. So we need a new total. So now on the product side, we have 11 oxygen. Okay, so now we have hydrogen and oxygen left to balance, and we're going to leave oxygen till the end. So let's balance hydrogen. So on the reactant side, we have 12. On the product side, we have 2. But we can get 12 on the product side if we put a 6 in front of water. So now we have 12 hydrogen. Now let's see how many oxygen we have. So we've got 5 CO2, that's 10, plus 6 H2O, that's another 6. So we have 16 oxygen. Now let's balance the oxygen. So in the product side, we have 16. We need 16 on the reactant side. We can get that by putting an 8 in front of O2. That gives us 16 oxygen, and everything is balanced. Okay, the last tip is that you can use a fraction as a coefficient, but it can't be in your final equation, so you then have to remove it by multiplying all the coefficients by a whole number. Okay, and some people really like this tip, and some people it confuses them. So you'll have to see if it works for you. So let's look at this example. Sodium plus water makes sodium hydroxide and hydrogen. So we'll set up our table. We've got sodium, hydrogen, and oxygen. We've got 1 sodium, 2 hydrogen, 1 oxygen on the reactant side. On the product side, we have 1 sodium, 3 hydrogen, and 1 oxygen. Okay, so everything is balanced except the hydrogen. We've got 2 hydrogen on one side and 3 on the other. So you could start by, so you need more on the reactant side, so you could put a 2 in front of H2O, and then you'd have 4 and 3, and then you can keep going back and figuring it out. Or you can use a fraction. So if I were to put a half in front of this H2, I would now have 2 hydrogen on that side. I have 1 hydrogen from NaOH, and then a half of an H2 is just 1 H. So I've got 2 H's. So it's balanced. Just by putting that half there, it's balanced. But it's not a proper way to write it. We can't have fractions. So what we do is we multiply everything by a whole number that would get rid of the fraction, which is generally you multiply by the denominator, which is 2. So if we multiply that by 2, we have to multiply everything by 2. Okay, so all of the first 3 had an invisible 1, so that becomes 2, and then a half times 2, just a 1. Now, after you've done that, do a check and make sure you're balanced. So we now have 2 sodium on the reactant side, 4 hydrogen, and 2 oxygen. On the product side, we've got 2 sodium, 4 hydrogen, and 2 oxygen. So we're balanced. So those are all the tips I have for you. And as I said, you need to figure out what works for you and practice, practice, practice.